Hi, I'm Nigel Hicks and welcome to Lesson 1 in this course on understanding light and exposure, aimed at describing the crucial role of light in photography and at showing you how to make the best use of it. The greatest composition will produce a poor image if the lighting is wrong. Bright or dull, hard or soft, sunlit or cloudy, sunrise or midday, all these give different light qualities that need to be used in the best way to generate the best images. In this first lesson I help you understand what light is, why it acts the way it does, why things don't always come out the way you hope them to, and how the digital camera goes about controlling the colour of light under a range of lighting conditions. So what actually is light? The whole cosmos is enveloped in electromagnetic radiation, waves of energy, the great majority of which is invisible, though detectable with the right equipment. ER, as it's often abbreviated to, ranges from very high energy, high frequency cosmic rays at one end of the spectrum, to gamma and X-rays, to very low energy, low frequency radio waves at the other end. As we all know, some of this ER can be both dangerous and highly useful, whether X-rays in medicine or radio waves in telecommunications. In the middle of this vast electromagnetic spectrum sits visible light, that small segment of the ER spectrum that our eyes can see. Other well-known forms of electromagnetic radiation include ultraviolet light, which sits just outside our vision at the high energy violet end of the visible spectrum, and infrared lying just outside our vision at the opposite low energy red end. The principal colours we recognise in the spectrum are red, orange, yellow, green, blue, indigo and violet. Each colour has a slightly different energy level, but much of the time all colours are present around us in varying balances. When there's an even mixture we have white light, which is roughly what we have during the middle of the day. We've all seen a rainbow, and this is one of nature's best ways of showing how white light is made up of a mixture of different colours. When rays of sunlight pass through water droplets suspended in the air, whether rain or spray, the water bends those rays. Each colour is bent by a slightly different amount, breaking the sun's white light up into its component colours. We can only see this when our vision is directly in line with the direction of the light, in other words, with the sun right behind us. The result is the stunningly beautiful, narrow, curving coloured band we call the rainbow. The order of the colours in a rainbow is always the same: red on the outside, as is bent the least by the raindrops, and violet on the inside, as is bent the most. We don't need to have all colours of the rainbow present to make white light. Only three are needed, known as the primary colours: red, blue and green, which is quite different from pigments such as paint and inks, where the primary colours are red, blue and yellow. All the other colours can be created by different blends of the three primary colours. This is often represented diagrammatically by the colour triangle, with each primary at one of the triangle's apices, the primaries blending to make the other colours along the triangle's sides. Each primary has a complementary or opposite colour: magenta for green, yellow for blue, and turquoise, also called cyan, for red. The presence of any of these complementary colours reduces the effect of their respective primary. Their relationships can be represented in the colour triangle, each complementary sitting at the midpoint of each side, opposite each relevant primary. Alternatively, all six colours can be shown in a colour hexagon, with each occupying an apex. A knowledge of this is critical in photography using film, as filters often have to be fitted to the camera lens to correct for colour imbalances in the light. With digital photography, however, the camera is usually set up to do this automatically, with the photographer barely having to think about it. It is still useful to have an understanding of it, however, as doing so makes it easier to understand how to use the camera's white balance settings, which will be covered later. Furthermore, a knowledge of primary and complementary colours is still crucial in two areas: studio lighting and in computer image manipulation, both areas where you are likely to want to fine-tune colour balances.